So let's take a few moments to talk about types. C# is all about the types. A C# program, at its basic level, is just a set of type declarations and workflows to move between them. Every project type, whether it's a program or a DLL class library, is a set of type declarations. Namespaces are used to organize your type declarations for uniqueness. Conceptually, a type is just a template. I want you to think of a type as a template for creating a data structure. Types specify the characteristics of whatever it is you're attempting to model in your code. I'll go back to the example of a library card. It might have a name, a card number, a create date. Methods of a library card could be things like checking out or returning a book. Our custom types, like classes, will contain data or fields and behavior, which are called methods. There are several predefined simple types that .NET gives us out of the box. These simple types are the building blocks of more complex code expressions. There's 11 numeric types. We also have a type called char, which represents one character. Chars are always put into single quotes. So for example, single quote, the letter A, single quote. That is one character. Last is the bool. A bool can only be two values, true or false. Booleans are usually used to make decisions. If something is true, do this. If something is false, do that. First, let's talk about the simple types that represent whole numbers. There are 8 of these, but really conceptually there's only 4, because each of them is a pair. One of them can contain negative numbers in the range, and the other one is called unsigned, which means it can only have positive numbers, but it basically doubles up the range. If you're writing a highly performant application, it's generally good to use types that only have the range of numbers that you absolutely need. So if you had a list of numbers, say between 1 and 10, it would make sense to use a byte to represent that. Now in these days when we have lots of computing power and lots of memory available, developers tend to be a little bit lazy and they'll just go to int for every whole number. And most of the time that's okay. As you can see though, from smallest to largest, we have byte, short, int, and long. We can also represent fractional numbers in our code. There's 3 types for doing this: the float, the double, which is bigger than a float, and the decimal. All of these types can hold very large numbers, but floats and doubles are what we call floating point values, and this means they're not perfectly precise. And if you go take a computer science class, they'll explain to you why this is. But basically, it's very hard in binary to represent decimal values. So floats and doubles, very fast at math, great for scientific calculations, but you should not use floats or doubles for money, because if you have many steps in a financial calculation where rounding might occur, these imprecise values can cause rounding errors, which in the finance world is unforgivable. So always use a decimal if you are representing money. Last, there's a couple non-simple types that are built in that I want to draw your attention to. A string is a sequence of Unicode characters. String data is always represented by double quotes, so if we have a single character that's a char type, we use single quotes. For a string, we use double quotes, just like in our Hello World example. We can add 2 strings together using the plus sign. This is called concatenation. So for example, if we have the string hello plus the string world, that would produce a single string, hello world. We also have a type called object. An object is the root of all types in C#. Everything is inherently an object. And later on in the course, I'm going to show you how we can convert anything into an object type, and then we can convert it back to the original type. This is often called boxing and unboxing. C# is a strongly typed language. And what that means is that every variable, constant, and expression must have a type. Methods will specify input types and return types. The compiler uses this type information to make sure that everything you do is type safe. So for example, once I declare that a variable is a type of integer, you cannot add a boolean to it. So in this block of code, I declare an integer a and I set it equal to 5. I can declare a second integer b and set it equal to a plus 2. That's perfectly fine. B would have the value of 7. Then I can declare a boolean called test, and I can assign it the value true. And if I try to say int c equals a plus test, Visual Studio is going to underline it in red because we can't add 5 to the value true. That doesn't make any sense. So remember that everything is a type. Console, in our Hello World, was a type. There are types built into the .NET framework for working with file system, network connections, collections, dates. We can write our own types that have their own properties. When we start building these real programs, we're going to be passing a lot of types around, and it's very important that all these types be compatible.